Hi guys, welcome to another tutorial of data science course. So today we will be discussing about IQR, that is the interquartile range, right? And what is meant by 75th percentile and 25th percentile, that is the Q3 and Q1. When I said in the last lecture that the formula for the IQR is Q3 minus Q1, right? So today we will be seeing that how to plot Q3 and Q1 in this particular graph. When I say that Q3 is the 75th percentile of the graph and Q1 is the 25th percentile of the graph, right? So what is meant by that? So if you see this graph, this particular rough graph, I made a rough sketch of that, but we can see from this graph that it has the middle point that is known as median. Median means the middlemost value, right? And in the next formulas now, the median will be denoted as Q2, right? So when we'll say Q2, so that will be meant by the median, right? But if I say Q3, so that is this point will be, this particular point is meant by Q3, that is the 75th percentile of the graph, right? But when I say Q1, that is the 25th percentile, so this will be the plot of Q1, right? So basically this graph is divided into the two parts, which is the 50 and another 50 percentile, right? And that 50 percentile is divided into another 25 and 25 percentile of the graph, right? So the median, the middle point is the median, as we say that median is the middlemost point, that is the Q2, and the point before the median, that will be the Q1, and after the median will be Q3. So the order goes Q1, Q2 and Q3, right? So this graph is basically divided into two parts, 50% and 50%, and that is further divided into 25 and 25. So the total will become 100, and when we have to find the IQR, we will simply subtract the 25th percentile of the graph from the 75th percentile of the graph, right? So that's the formula of the Q3 and Q1 of the IQR, where we subtract this, right? And if I say that the data is in range, so what is the meaning of range? We discussed that range is the you can say the difference between the maximum and minimum value when you just compare that what is the maximum and minimum value, and when you subtract them, so then you find the range, right? But when I said that there is no range, or the range is zero, or it is constant, so then we can say that the data is same everywhere, right? So from there the concept of outlier comes, right? What is an outlier? So outlier basically is the minimum or maximum of any range of data, right? For example, I have a data 1, 45, 50, you can say 60, or I will make it 10, right? 1 looks odd here. And so to predict that the model, and from here I just keep 1 here you can see that the order goes 1, 10, 45, 50, 16 and 95. The maximum value is 95 and the minimum value is 1. If you just compare this data and you just look at this list of the numbers, you can see the minimum is 1 and the maximum is 95, right? So here 95 will be the outlier and 1 will also be the outlier. Means outlier simply the thing that is out of the data, right? So outlier is simply the thing that is out of the data, and everything has a type. So outlier will also have a type, right? So outlier basically is of you can say is of two types. So the first one is lower bound and the other one is upper bound, right? First one is lower bound and the other one is lower bound. So the formula for the upper bound will be, it is made by the you can say it is made by the IQR only, right? It is made by the IQR only. I don't think why it is not changing here, so let's leave it. So outlier can be is of two types, basically the lower bound and the upper bound, right? Lower bound and the upper bound. Let me write here. I don't know why it was not changing there. So outlier is of two types, lower and upper bound. It is very important the questions, the maximum questions, the maximum concepts from the outlier is basically from its type only. You can't just predict the meaning of outlier without knowing its types, right? What do you mean by what do you mean by an outlier? You just simply say the maximum or minimum value, but the questions, the concept will be clear when you just know how to detect an outlier in a particular range, right? So that will be done with the help of IQR. If I say that the outlier is upper bound, that will be equal to Q1 minus 1.5 into IQR. That will be simply equal to Q1 minus 1.5 into IQR, right? But if I say that the outlier is lower bound, what will that mean? That it is simply Q3 plus 1.5 into IQR. Means where we just consider the 25th percentile, that is the upper bound, and where we consider the 75th percentile, that is Q3, that is the formula for the lower bound, right? So this is basically how to find an outlier in a particular range of data, right? Here, if we know the IQR, right, we will be simply able to find what is the outlier in this particular range, that is 1 and 95, right? So that is basically the meaning of outlier. So when I say data is in range, so if a data is in a particular range, that it has the difference same everywhere, 2 का difference आ रहा है हर जगह, right? So that is the range of data, that it is having an even pattern, an odd pattern is going on, a particular pattern, that data is in range, that means that it has a particular pattern. But if I say that data is in range, but in the terms of outlier, it will be meaning that there is no outlier present. You see now, if there is no minimum or maximum value and the data is going in the same range everywhere, so there will be no outlier detected, right? So that means simply that there will be no outlier, right? So now come to the another part, that is Bayes theorem, right? Very important theorem for the concept of conditional probability, posterior probability, right? The independent and dependent events, that you should be aware of, that what are the independent and dependent events, right? So Bayes theorem, basically what is the use of Bayes theorem in statistics, why we are doing this theorem, why we are learning this theorem. So basically we get data classification from here. So in the last lectures we learned that we use some models in data science, that are the classification, regression and clustering model. In clustering we do the cluster of the common data. In regression we just make an equation from the prediction and assumptions y equal to mx plus c, and in classification we just classify our data, right? So that data classification is done with the help of Bayes theorem. Bayes theorem helps to do the data classification, right? Basically what happens in data classification when we used Bayes theorem here, here a popular classifier is used, that is known as the naive Bayes classifier. After we get the probability of data distribution, we just use this naive Bayes classifier, right? And with that, with the help of this classifier, we just apply it in the formula of the Bayes theorem, and we just predict that what can be the event, what can be the probability that the model is good or not, model is defective or undefective, you can say model is effective or not, right? So we just predict the accuracy of a particular model here, right? So to predict that the model is defective or not, is effective or not, right? To find the accuracy of the particular model, whether it is classification or regression or any other, we simply use the Bayes theorem, where we do the data classification, where we use the naive Bayes classifier, right? So the particular formula for the Bayes theorem, where you are given a particular hypothesis, right? And where you are given a particular assumption and you are given a data point. So simply just you apply the formula. It is written as h by d. The small h stands for the hypothesis and the capital D stands for the data point, right? So P, probability of h by d, will be equal to probability of d by h into probability of h upon probability of d, means probability of data upon the hypothesis into probability of hypothesis upon probability of the particular data point, right? So this is basically all about the Bayes theorem. We will be just practicing the questions on it also, that how to find the probability of a particular event, right? So next come to the next point, that is about the new model. So whenever we make a new model, that is just doing the work on the data assumption, right? The model just predict 4 types of a particular result when we do the test, and whether it is t-test, ANOVA test, Carl Pearson test, right? There are n number of tests that we do to predict a new model, to just test and train a new model also. So basically that new model will work on one thing only, that is the data assumption. You can say that data assumption is the principle of a new working model, right? So it will be giving the 4 main result, that is false positive, right, false negative, true positive, and true negative. So what does that mean? That there are 4 results from a particular model, but how does it will give the false positive? So false positive means the statement that is given, the data that is given, that is positive, that is giving a positive result, but actually it is negative. It is negative in the real life, right? The assumption given is positive, but actually it is negative. So that is known as false positive test, right? But when we come to false negative, the actual data will be positive, but the assumption will be negative. The assumption that the data given, the hypothesis, is negative, and the actual data will be positive, right? So simply you can just find out what does the true positive and the true negative mean. So when we find out all about this, we can just predict that the new model will be giving a false positive. Means the new model can also do the mistakes, right? It's not like that a model is a machine and it will not do any mistake. The machine is a very dumb thing, right? So it also does some mistakes when we are given some a statement by a machine, and it just gives us the wrong output. So we can say that the test is whether false positive or false negative, right? So that means that a new model works only on the principle of data assumption. So this is all about today's lecture. In the next, we are just continuing with the IQR. We will just continue with the EDA, that is exploratory data analysis. That's not over till yet. That is a very important and lengthy topic, right? And very important also. So Bayes theorem we did here, and IQR and outliers. So I hope you understand it and you are clear with it, right? Thank you so much. Have a nice day.